So I'm going to write my function. Oh, okay. Before I even do that, if I put my x-intercepts, like let's pretend it's here. Let's pretend it's here. That's not symmetrical. Pretend it's here, right? That means you go left, like you go -2, 0, or +8, 0, or 6, 0, or 1, 0. If you notice, the y is always 0, right? The y is always 0. This is when the y is 0. So instead of, so what I want you to do is, instead of writing, well, this is y, I'll show you. This is y right here. Remember, this is y. Put that in a different color. This right here is y. And I want to make it 0. Now, usually we don't like see it this way. Usually we put the 0 over here, so I'm going to write it like this. 12x squared minus 12x plus 10. And I will put equals 0 here. Okay, now we're going to do what we actually, I need more room, so I'm going to write a little higher. Minus 12x plus 10 equals 0. Okay, now we got to find out, we got to solve for x. We got to find out which x or which x's make this 0, right? So I'm going to do this in orange, I guess. So 2 times 10 is 20. Factors of 20 that create -12. So we have 2 and 10, right? But 2 and 10 will make +20. 2 and 10 will make +12. But we have this -12. -12. So we need this to be negative. But a negative times a positive would be a negative. So this needs to be negative. Negative times a negative is a positive. Negative with a negative gives you more negatives. Yeah, that's the right one. Okay, so I'm going to write this as 2x squared. Oh, just so you know, I'm bringing this down. Minus 2x minus 10x, and then plus 10 equals 0. I can factor out a 2 from here. Oh, and an x. So 2x times x is 2x squared. 2x times, so minus 1. I'm going to copy this. Equals 0. Okay, so what times x minus 1 gives me -10x plus 10? So we know this needs to be a 10. But a positive times a positive is a positive, but I need this negative, so this needs to be negative. Negative times a positive is a negative. And then fully factored or full factored form, I guess I'll use that. We have 2x copies of x minus 1. We have minus 10 or -10 copies of x minus 1. So we will have 2x minus 10 copies of x minus 1 equals 0. So then I'm going to bring this up here. Remember, I need to find what x is. So I need to figure out when to make, like what number, what x would make this 0. Because remember, 0 times anything would be 0, or 0 times anything would give me 0 here. So plus 10 plus 10. 2x equals 10 divided by 2, x equals 5. Cool. And then I have this x minus 1. We can make that one 0 also. And we add 1. and we get x equals 1. So these are our x-intercepts. This is when the y is 0. This is when it's like on the, like you haven't gone up or down, it's on the x-axis. So this means my x-intercepts, I guess I can put, yeah, I'll put these in purple too. That means my x-intercepts are at 5, oh, yeah, 5, 0, and 1, 0. Because remember, the y was 0. We made this y 0. We moved it over here, but the y is 0, the y is 0, the y is 0, so the y is 0 right here. Y is 0. So I'm going to go to 5, 0, and 1, 0. Now let's just double check, because they're supposed to be symmetrical, right? So they should both be 2 away. Yeah. And even here, that is 1, 2, 3 away. So I can actually put another one here if I want to. So 1, 2, 3 away from my line of symmetry. 1, 2, 3. Should be like somewhere around there. Actually going to extend my line of symmetry so yeah, I can see the symmetricalness. And then I guess I'll use orange, I guess. So it needs to go through here. Remember, you can use your calculator to check to make sure. That doesn't look too nice. I could do a little bit better. Supposed to be symmetrical, but you know, that's good enough. Make sure to put the arrows at the end, the arrowheads. I just didn't want to get in the way of all that stuff. So, and oh, I never did this statement. So the quadratic function has 2 zeros. I made them orange. Oh, purple. I made them purple. Yeah, has 2 zeros, or they're called x-intercepts. Intercepts at the locations 5, 0 and 1, 0. Okay, then we graphed it. Now we're done. Okay, thank you.